Abhinav. Sachin is
Hi, Abhiyana.
Hi, hi, hi.
Anna, Uncle, Abhi, you have all the relations here, Abhi.
Yeah, yeah.
First time she called him
I,
uncle, now he's calling him
I
Anna.
am everybody's everybody to them.
Everybody is everybody, okay.
And last time she called him
Then I want someone to
uncle.
call you as grandpa. Let
No, no,
us
no.
have that relation also.
I am already old enough to be called as grandpa. Not a problem.
So what are we going to see today? Anybody know?
I forgot.
who is controlling?
Who's controlling the helicopter?
Yes, exactly.
See, Tanya raised her hands. You should raise your hands before asking.
Okay.
Okay. So you have any guesses who's going to be controlling it? Anybody?
The robots?
Yeah, okay. And what are they called? Can you tell me what are they called?
இருக்கா எல்லாத்தையும் போட்டோட வச்சிருக்கேன் பாரு. சரி பார்த்தேன் ஈஸியாக வைக்கிற மாதிரி.
Okay, I'll tell you what are they called when we get to that point. So shall we start?
Yes, Abhi, you can start now, Abhi.
I'll start. Okay.
Yes, yes.
So hi everyone. So I hope everybody enjoyed the last week, and most of you are back into the story to know what is happening this week regarding who is controlling the helicopter.
Yes.
We know who is Abhi. So Abhi is in all the center of the solar family. So we got Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and the last guy Pluto. So what did we see before? We saw who is Mars, what are its unique characters, what is so unique about gravity, what is unique about its atmosphere, all these things. And how is it so different from Earth? Its climate, is it very hot, it is very cold, all extremities we saw across the surface of Mars. And we found new places, a lot of craters, a lot of planums, a lot of valleys, all these things. Then towards the end, that is when we saw our new buddy, a toy from Earth. So it was in where did Earth's robot go? So towards the end, I was in my spacesuit going around Mars everywhere. So suddenly came the robot with the telescope, and there was a helicopter. It had a rovering point there, and Moon got very excited. Yay, it's a helicopter. So, and I was looking at my telescope. That's our telescope. And Moon jumped and got hold of the helicopter's tail, and they started going around. It started going around, and Mars was very concerned. Oh no, you have to be very careful, it is very windy place, don't fall off from that helicopter. I was worried, who is controlling this? So that is the question, who is controlling the Mars helicopter? So we are going to find out in just a few minutes. So I asked that question. So Mars was ready to answer it. It said, nobody is controlling it. This is an autonomous helicopter. What is autonomous? Autonomous is something where a person, a human, and Earth has programmed it and sent it to Mars to go around the space. I think one of my buddy doggy is barking in the back. Wow, wow. Maybe it is sensing someone is coming close by. Any guesses who is coming? Earth is coming. It said, did someone say my name? Hey Earth, why did you program kidnap our telescope? Why did you do that? And Mars was also very curious. That and put Moon down, I say. Your flying toys taking around the Moon everywhere. And no worries guy, cool. This will land in a few seconds. And as he said, suddenly the helicopter went somewhere and parked itself. And Moon jumped back to the spot next to Abhi. Next thing I asked, cool, how did you know that? Did you write some codes? I know someone is also very interested in writing programs. They're taking gaming lessons and all. So is Earth is also doing the same thing? I asked. Actually, that's one of the many things I can make it do, said Earth. So, see, I told you, all this Earth does is always play with toys and park it in my Mars. So I'll see what I can do. So I told, no. Are you interested to know more about this, or do you want to play with the toys now? So what happened next? I'm always curious. So I said, yes, sure, take us and tell us more about it. And Mars was like, me too. I just want to know what's the reason you do this all the time, always leaving all the toys in my space. Hey, Moon was very excited. Yay, count me in too. I want to do that. And then we started learning about it. So what is that we are going to do? We are going to know what is this helicopter all about. So this is called a Mars helicopter. So it is a very small helicopter, cute little helicopter. It's just about the size of a very small computer or a laptop size, that's all. So it takes off from Mars surface and up it goes. How tall it goes, we are going to tell you. So the toy is looking at it and it is seeing it fly to a height, and then it takes a look around and goes to that space and takes photographs. So what is this called? What is the name of this helicopter? This is called as Ingenuity. It means intelligence. So it is going to go there to Mars on February 2021. That is some 6 months from now. So now all the questions that I have, so many things I have to ask. So I asked one by one. So how big it is? So Earth told me its body is very small, so small. It's like as in the size of a small laptop, but its blades, that is the flying wings, are very, very big. How big? So it is needed so that you can push a lot of air down. So you know that helicopter, usually it has a very big fan on top of it. So the fan spins. It's called a rotor. So that rotor spins faster and faster so that it pushes a lot of air below and it goes up. This is called thrust. And that's how you get flight. So that's how Moon can get hold of that helicopter and go around. It's a very small helicopter to carry Moon. So because we know, last week we saw that compared to Earth, Mars atmosphere is very, very, very less. It's just 1%. So you remember, this is how we saw. So we got lot of nitrogen in Mars, but very little, lot of nitrogen in, I'm getting feedback, one second. So a lot of nitrogen in Earth, but lot of carbon dioxide. So it is cold as well, it is very thin. So if the helicopter needs to go higher and higher, it needs to push lot of air compared to that of Earth. Next, I told you it is just 1%. So it has to fly in a really thin Martian atmosphere. So I asked, is that true also? Yes, because it's a very small helicopter with a very long wings. So it's about 4 feet wide. So what is 4 feet? It is like how tall I am right now. So I am about 4 feet now at the age of 8. So all these small kids we talk about, they're all of 4 feet high. So the total helicopter is just 4 feet across, and its blade spins at 2800 revolutions per minute. So it's like looking at a fan spinning very, very fast. How fast? That's what Moon asked. So it is about 10 times faster than what we see on Earth. Next, how much does it weigh? So we have a question. So you want it in Earth's weight or Mars weight? Mars was our case. That is both different. Now tell me, which number do you want? So we said, tell us first in Earth, then we will tell you which is in Mars. So it is about 4 pounds, that is 1.8 kilograms. So it is the size of a telescope, sorry, it is in the size of a laptop, and it is also weighing in the size of a laptop. So this is what we saw last week. So it's about 45 kilograms when you compare it with Earth's weight to a weight of a boy in Mars, 17.23. So now how much is the helicopter? So it is 0.68 kilograms, that is just around 600 grams. That is, if the helicopter weighed about weight of a laptop in Earth, it will weigh about weight of a smartphone, your mummy and daddy's smartphone. It's a very small smartphone, that's all. Next, how long can it fly? Because you know, moon is very curious to go around the Mars with the helicopter. So it can do 5. So it will take off, go around for some time and come back and land. That's how Earth knows that it will be very few seconds, it will come back down to the Earth to take a rest. Why? Because it needs to recharge its batteries. It can't spin all the time. So it is known to be self-recharging batteries. So now we know that how tall can it fly. It can fly about 15 feet. That is 3 times taller than Abhi, young Abhi. Okay. So it can also take photos. So you saw in the video that it can take a lot of photos. So how good is the camera? We always ask, what is the megapixel? How is the megapixel of the camera? So it is around 13 megapixels. That's very big. If you compare it to the photographs that was sent in the first, this 13 megapixel is going to give you even more good quality images when you join on all the images and send it back to Earth. But now the question comes, how will it talk to the Earth? That is going to be a next question where I got curious. Will it be not very cold? Yes, obviously it is going to be cold, because we saw that compared to Earth, Mars is very very cold, about minus 140 degrees Celsius. So it needs to keep itself warm all the time. So what it does, it uses the internal battery to have a small heater inside, so that that heater can make it warm by the night when it is sitting idle. So in night you can't use the camera and you cannot use the blades to fly in the Martian atmosphere. So it has to take rest and keep charging and heating the internals of the helicopter. So that's what it does when it's in the night. So every day it has to have that battery capacity to be filled. So how big is that battery? It's a solar rechargeable battery. Instead of putting a charger, plug and charger, it has to take up solar energy and convert it into electrical energy. So it's a DC battery, direct current battery. So how big it is, how is going to get charged fully? So it will take around 12 hours, because sun is always up in the sky, yes, but it rotates itself, because Earth and Mars rotates in the same space. There is day and night cycle. So when it is day, the battery gets charged. When it is night, it has to sleep. So for 12 hours a day, it will have around 3 watts of power. Then you know what is 3 watts, but how is it equivalent to that of Earth? So it's around 360 watts for every rotation of the flight. So how big it is compared to that? So it's around 1, 2, 3, 4, 5, 6. 6 light bulbs. That is the total amount of energy that it is producing for every second. So the helicopter takes about 360 watts to finish one cycle of flight. So that's how much power it can consume in a day. So now all these things it does. So only it has to talk to itself, or it has to go around with all the programs that is given to it? No, it can speak to the rover. What is that rover? This is very new to us. The rover is the name of the toy. So what you saw in the last couple of weeks that is roaming around in Mars, it's actually a rover that is sent by the humans to explore Mars. And also Earth is doing a lot of programming work in the background. So now it comes. So it will speak every second? Not entirely, but it has to do some kind of communication with the satellites so that it can be picked up and we can able to see what is the thing. So whenever it takes photographs, it doesn't have a lot of memory to store it. So it will send the images to us and we have to pick it up and we have to open the image and see what it has sent us every day. So we use that using radio telescope. I told you about radio telescopes 2 weeks back. So there are a lot of telescopes which can collect information. One of the telescope is a radio telescope which picks up the signal from Mars and it telecasts it to the scientists across the world. So normally if Earth and Mars are very close by in their orbit, it takes about 4 minutes for communication to pass. But if they are on the opposite sides, so if they are going away from each other, it will take nearly 20 minutes. So if I send a hi, another 10, 15, 20 minutes later, it will go and say hi to the Mars rover. So we can't put all the time every time to say wait, go left, and 20 minutes later it will take left and 20 minutes later it will take right if I say go right. So instead of that, the programming team of scientists have taken effort to do autonomous motion. So it will go depending on what it sees. So that's why it has a lot of cameras. 13 megapixel camera is used for that. So now it also has microphone. So scientists are sure that this is how it is going to sound when it is going to go around in Mars. So I'm going to put the microphone to you so that you can hear how it sounds. 1 second. Checking the blade for the first time for rotation. This is the sound it makes. So the flight is just 2 minutes long. less than 2 minutes. Depending on the battery charge, it will go around for 2 minutes. So now we are back, and that's a lot to take, I said. But we still don't know a lot about this rover that just you introduced as a toy. Yeah, we have to speak about it, but let's take the telescope now and we'll go somewhere far distant, and then we'll talk about it, said Earth. Yeah guys, please go, because it's very hot. It's getting very hot and night is going to come. You better go somewhere else so that we can continue this. I was like, why Mars? Why are you asking us to go? Are you not coming? Yeah, please come, said Earth. No guys, it's okay. I have got work to do. You carry on. And then it said bye-bye. So Earth left, followed by me and Moon. And then the rover picked up the telescope and went, followed by the Ingenuity helicopter. So where did we go? We went back to Earth's home. And I changed my spacesuit. So I am now free. I am away from that white color spacesuit to my normal jeans pant and t-shirt. So hey Earth, I am back in my normal dress. Now tell us about the rover and other spacecrafts. Yes, sure, let me call it. So as soon as it called it, so it came back like a puppy dog, but it was filling all the space in front of Earth's house. So now we have to go to somewhere bigger. So we said we should go to the back of the house, because there is a very big open area there. So that's where we went. And then we started asking about what is this. So Earth told us this is made by the scientist to do a lot of exploration of the space. So now what is this called as, or how do they drive it? So they use autonomous programming. So they have to write a bunch of codes to make it go independently, and they have to follow certain rules of physics to make it maneuverable across the space. Now what is it called? So as I told you, it's called a rover. It's a rover spacecraft. It goes around. Roving is something called moving silently and slowly. It moves very quietly. Bzzz kind of motion it will go. Not like vroom vroom kind of sound. It's just comical way of telling it. It's a very slow. It goes around 3-4 kilometers per hour. That's very slow. Then what are the other kinds of spacecrafts? So there are many. So the first one is flyby spacecraft, orbiter spacecraft, atmospheric spacecraft, lander spacecraft, rover spacecraft, penetrator spacecraft, observatory spacecraft, and communication spacecraft. There are so many things. I was like, oh god, there are so many things. How are we going to remember all these things? Earth said, no, we have already seen most of it. It's just in a different name. So then something else happened. There was a distant rumbling sound, as if something is coming closer. Kind of sound. Then there was a horn sound. Pam pam. What is this sound? So Earth said, I've got a surprise friend for you to tell about flyby spacecraft. Then it sounded like a bus. And Earth said, correct. Yes, rover, just move and give a space for the bus. What bus came? A school bus came. Yeah, it's a school bus. So any guess who is in it? That's the question. So who is coming in the school bus? So that is what we are going to see in next week. So someone is going to come and tell about what is a flyby spacecraft. So what did we see today? We saw what is an autonomous helicopter, how is Ingenuity built and what are its features, what is the battery capacity. It is around 6 light bulbs of battery capacity. How long will it fly? It will fly for 1 minute 30 seconds or less than 2 minutes. So it weighs about just 1.5 kilograms in Earth weight, and it is just around 600 grams in Mars weight. That is the size of a laptop in Earth, and it's a weight of a mobile smartphone in the Mars atmosphere. So other types of rovers and other spacecrafts we are going to see next week. So someone is going to come and show you what is the spacecraft about, flyby spacecraft. So that's it for today. Okay, how do you like it? Any guesses, any questions? Okay, any questions? So who guessed that Earth is going to come this week? Everybody guessed. Okay. Why? Okay, Mars was good, but before that someone in our team told last week that Earth is the one who is going to come next week. Remember? So every week we are going to introduce a new person, and through them we are going to see the other things that are going to come. So next week we are going to see someone very new. They are going to tell about what is flyby spacecraft and other things. Okay. So any questions for this week? No? Okay, I will ask you a question. Okay. How much do I weigh in Mars? So if I am 45 kilograms, how much do I weigh in Mars? 38. Very
I
good.
don't understand the question.
Okay. So you take one example. So we have different gravity. Mars has a different gravity. We have different. Earth has different atmosphere. Mars has a different atmosphere. So every time when you pick something from Earth and leave it in Mars, it will have different weight. Correct? So you know when they go for spacewalk, they will jump like this. Have you seen spacewalk? Have you seen videos from moon? Yeah, because they will jump around. They can't walk because gravity. Yeah, because gravity is not constant there. It is not like 9.8 meters per second squared here as in Earth. So it has to be slightly different. So it will be slightly less. We in Earth call it as space gravity. That is depending on the planet that you are standing or the space where you are at. So when you are in outer space, you will match to the gravity of the sun. So when you go around with the gravity of the sun. But when you land on the surface of Mars, your gravity changes. So that's how your weight in Earth, it is around 45-50 kilograms. It will be around 30 to 36 kilograms in Mars. Is it okay? Did you get it? Still not getting it. Okay. So how many light bulbs do you need for the helicopter to fly? How many light bulbs do you need to charge?
6.
Yes, 6 light bulbs.
6.
So it is like carrying a power bank. 1 power bank, 2 power bank, 3 power bank. You know, mommy, daddy always carries a power bank to charge their phone, charge their laptop, all these things. So the Mars helicopter carries a power bank, and that power bank can only do 6 light bulbs at a time.
Why if we stand on Mars, there is a different weight, and if we stand on Earth, there is a different weight?
That is because of 2 things. One is because the atmosphere where we are standing, we are in the effect of the pressure at the atmospheric level. Okay, I'll put it in a different way. Okay, you have 2 balloons. Okay, one balloon is filled with helium, one balloon is filled with a normal, you breathe out carbon dioxide. Okay, it is filled with carbon dioxide and a mixture of other gases. Which will flow higher and which will flow lower? Which is lighter? Okay, in a different way, which is lighter and which is heavier? Yes. So because the pressure exerted by the helium gas is very 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 less, so what happens is it according to the outer atmosphere, that is the air outside of the balloon, it's so light, so it can flow up. So compared to the earth, we are very big, so we are very heavy, so we will go down. But when it compared to Mars, we are completely light, so we will go up, so we will fly light slightly up. So this is just comparing Mars, but there is a moon of Saturn that is called Titan. Titan is a very big moon of Saturn. So when you jump from Titan, if you jump very high, really really high, the gravity is very low, you will suddenly fly towards like a Superman. You will go fly tall, you'll go reach the sky of the Titan, and then you will be suddenly caught by the gravity of Saturn. So it's a very light, you can even fly in the Titan's atmosphere, you'll feel like a crow. So that's how gravity is. Gravity is very tough. It's like how Einstein or how Newton tried to find answers. Newton had an apple falling on his head. Tongue, the apple fell and he had a discovery. Einstein took a different way. He looked at all the stars are out of the sky and tried to find the reason why gravity is working like this. You know who's Einstein? The one with a lot of white hair. He'll say all the time. He'll put a tongue out smiley. Albert Einstein. We'll see him later. He's going to come in the astronomy class maybe some 10-15 episodes from now. That is a little far ahead of time, because time is what he is very good at. Did you get what is gravity? Did you understood what is gravity? Okay. Any other question? No question? Okay. Anything else you have, ma'am? You have any questions to ask?
Anyone has any questions? No?
No? Okay.
Okay, you know what are the different, he was telling the different spacecraft, right? Okay. So next class I'll come with more questions, okay? Let's see.
Please do, because I'm also very happy to see someone is coming with a lot of questions.
Lot of questions. Okay. I think Lakshya would have asked many questions.
Oh, she's on leave today?
No, she's there.
Okay. You can ask any questions you can ask. Last week you asked me whether I'm an astronaut. I was very happy. Yeah, I'm an astronaut. I wish I was an astronaut. If any one of you joins an astronomical body, maybe like ISRO or NASA, just call me in. And when I become very old guy, I will come with a stick and see NASA or ISRO. I have been to ISRO, but as a visitor and as a technical person I have gone in, but not as a scientist. I wish I was a scientist.
So anybody has any question? Like you can ask like any possibility for life in Mars. Is there any possibility to life for any life in Mars?
Actually, there could be. We are not sure, but what happened is Mars used to have a very thick atmosphere some billion years ago. Unfortunately, there is a thing called greenhouse effect. That is a runaway experience which takes away all the good gases from our atmosphere. Because when carbon dioxide gets filled up, all the other good gases will go out of the atmosphere. That happened very long time ago. And sadly, it had made all the living things in the atmosphere, which we believe would have been carbon-based or oxygen-breathing organisms, to have died. So something like dinosaurs would have gone died. Sorry, what did you ask?
Riku, you have any questions, Riku?
Yes, ma'am.
Yes, you can ask.
What What weight will we be when we are in Mars?
What is your weight now? How much do you weigh? What is your weight?
10 kg, Rico?
No, that much I don't know.
Okay. Assuming that you are around 10-15 kilograms, okay? 10 or
No, no, she is around 20 kg.
okay, 20 kilograms, okay. 20 kilograms, you will be
Yes,
somewhere.
I'm 20.
Okay,
No.
20. So you will be somewhere around 12 or 10 or 12 kilograms there. Somewhere between 10 or 12. Depending on the place where you are standing.
Does Mars have any light in it, or is it very dark?
It has light and day. So actually, incidentally, because it has a lot of carbon dioxide in the outer atmosphere, the sky in the Mars is also equivalent to that of our sky because it is blue all the time. But it doesn't have other colors like saffron red in the early morning and on the evening, because you know how light plays with atmosphere. So when you are in the morning time, that is somewhere around 5:45 to 6:45, the sky is bright yellowish red color. Correct? It's a color of the sky when it is in the daybreak, and when it is going down in the evening, around same time, around 5:30 to 6, it will be slightly different tone of orange. But unfortunately, it doesn't happen in Mars. Mars always, the sky is always blue, and in the night time it is completely dark.
Sir, shall I ask? I have one doubt.
Yes, please.
In which color Earth is? In which color Earth, ma'am?
Earth is mostly in, when you see it from space, it is in the color of blue. Blue.
Oh.
And there is also another reason for it, because Earth is filled with nitrogen, a lot of nitrogen. So nitrogen is having a different spectrum is a very different value for you. Okay, I'll tell you one thing. All the colors that you see is made up of one color that is called white color, white light. So from sun brings the color, and that color is in the color of white color. So it's a very completely bright thing. So when you see a screen, mobile screen, it is white in color, right? So from the sun, it travels all the way and it falls on the surface of the planet Earth, and it bounces back to the sky. So the sky has a lot of nitrogen, and nitrogen will absorb every other color. So it collects indigo, blue, violet, indigo, green, yellow, orange, red and everything, but it only gives out the color blue. So you know the colors of rainbow, right? Violet, indigo, blue, green, yellow, orange and red. So it collects all the other colors, violet, indigo, green, yellow, orange and red, but only reflects out the blue color. So that becomes the color of the sky. So when you look from the above the earth, the water looks blue, and if you also stand in the end of the beach, you will also see water in the color of blue, but it's actually the color of the sky that is reflecting back on the surface of the ocean. Someone is giving me a question. Is water there in Mars? There is not liquid water, but there is cold frozen water in the southern pole, south pole.
Yes.
Yes.
Does Mars' moon shine like our moon?
Does Mars moon shine like our moon? And I'm not sure it does, because it is not made of silica or other reflective things, and since Mars atmosphere is not capable enough to how do you say refraction? Okay, refraction is another science concept. Okay. You if you look in your mirror, if you have a torchlight and if you put on the front of a mirror, how much of light can it bounce back from the mirror? If you take a torchlight, if you put it on front of the mirror, how much of light is coming to you and how much of light is going away from you? Any guess? Okay, compare it to maybe something like a black color paper. So if you take torchlight and point it on a black color paper, how much of light comes back to you and how much of light gets away from you? Maybe you can try it as an experiment. Okay, do one thing. You have any black color board or black color notebook? Okay, very good. So what you do, you go to a dark room, take Amma or Appa's mobile phones or some torchlight, put the light on the dark notebook, see if anything else comes into your face, bright light comes into your face, and take a mirror, go to a dark room, put it on front of the mirror. So both things will have a different level of light refraction. So okay, refraction is all about how light plays with your eyes. How many of you are wearing glasses? I think science is getting a little tough for me. So I have to go to the level of 8-year-old child to answer out a lot of these concepts. Okay, so your eyes are very useful for seeing light, and Mars atmosphere doesn't allow for you to see a lot of light, because the light that you see is already completely bright because of the very thin atmosphere. So when you go to a dark room and put light in the black color paper, you will see that there is no atmosphere in between your torchlight and the black color notebook. So if you are looking very close by, you will only see a black colored Martian moon like Deimos and Phobos moving across the sky. So it will go like that. If it is very close by, maybe you would be lucky enough to see some brown color or black colored asteroid going around, because it's mostly it is made up of carbon and silica based asteroids. So both Deimos and Phobos.
Anybody has any other questions to ask? Okay, so next week you have to come with a lot of questions, okay?
Yes, please.
I have a doubt.
Yes, please. Ask. Someone is asking, having doubt.
Why Jupiter runs very fast?
Very good question. Because see, the internal how do you say that? Okay, internal space of Jupiter is made up of lot of gases. So these gases like helium, hydrogen, all these gases are highly active. They are very active. So they are not willing to stay in the same space. It is like how you are right now. You are in quarantine and you don't like to stay at home, right? So like that, both these two gases, hydrogen and helium, are very reactive. So they like to go around the surface of Jupiter very fast. So it is like it is making the inner core of the Jupiter spin faster than everything else, because it is very massive, it is very big. So it is like how do you say, do you have, anybody has fidget spinner? You have fidget spinner? Oh, okay. A fidget spinner, you can spin around with it fastly. So it looks like a very small like this and you have to spin it around. So it is like that. So the fidget spinner of Jupiter is helium and hydrogen. So when it spins around, it goes really fast. So it is never stopping the energy from the helium and hydrogen to escape. So there are very massive storms that are going in Jupiter for the last 300-400 years. So when it rains for 10 days, maximum 12 days, correct? But in Jupiter, it has been raining for 300 years. There is a big storm called the Great Red Spot that Jupiter has in its forehead. That red spot is spinning at a rate of 7,000 kilometers per second. Like that, it will spin 7,000 times. So it's a very fast fidget spinner.
Okay, children.
Why?
Yes, Lakshya.
Why can we see green in Earth?
Sorry, come again.
Why do we see green and blue in Earth?
Oh, okay. Um, see, green is because of a pigment called chlorophyll. There is a pigment called chlorophyll in plants. This is an absorbent of a lot of color green. So that when it gets completely absorbed, it is helpful for the trapping of energy from the sun. So this chlorophyll is the process in which it can synthesize a lot of food. So all the plants are in the color of green, algae is in color of green, and leaves are in the color of green. So this makes it easy for the color green to process a lot of energy. Someone was asking about something about Saturn. Some question came about Saturn. Saturn or Neptune? Okay, Uranus. Yes. What is about Uranus?
Samyukta, yes.
Why is Uranus tilted in another direction?
That is due to a reason which even the scientists are not sure, but somewhere in the past, there is a planetary model. There is a hypothetical planetary model that two planets would have shifted axis. I'm sorry, it's supposed to be Neptune is in the tilting in the axis, not Saturn. Saturn is fine. Saturn is on the slightly tilted axis, but Neptune is the one which is going in the sideways. Or Uranus. Okay, sorry, Uranus. Uranus is slightly tilted in its axis. So what happens is every planet had a beginning as a planetoid some billion years ago. So that many billion years ago, it had a shift in its axis. So when it was closer to the sun, it was able to focus on its gravity on one place. So it was always looking at, if this is sun, so I take this microphone as a sun, so it was looking at the same direction at all the time. But suddenly when there was an impact from another astronomical body, say like an bigger asteroid or a bigger comet or something else, it would have flipped its axis or it would have gone in a belly roll. So that might be a reason why Uranus must have tilted completely in sideways.
Okay, thanks, Abhi. Like you have answered for a lot of questions.
Okay.
And children, for next week, you can bring with a lot of questions, whatever you have in your mind. You can just ask Abhi, he'll answer you. Okay?
Sure.
I have one
Okay.
more.
Who's that?
Someone is having one.
Tanishri,
Yes, ask me.
Yes, Tanishri.
how much weight will Neptune have?
Good question. Neptune is completely made of water. So it's not water, but it's filled with gases in a color of I'm not sure, but I'll just check it out and I'll tell you. I'm not sure it is very heavy because it's a very gaseous planet. So I'll check whether how big it will be and how much does it weigh.
Okay, Tanya.
Thank you.
Thank you, Abhi.
Why is Mars brown?
What's that?
Mars is not brown. Mars cannot be brown. Mars is in the color of red, bright tinted red. It's like it's how
Vermilion.
yeah, it's like in a color of vermilion because it is filled with a lot of iron deposit. Iron. Okay. Do you know what is the composition of red color bricks? Red color brick. Have you seen red color bricks? Everybody must have seen clay. What is the color of clay? Clay is brown in color, correct? Like that, in Vinayagar Chaturthi, some of you would have bought red color Ganesha. Right? So red color Ganesha is made up of red brick. Red brick has a lot of iron content in it. So Mars is made up a lot of iron based contents in the surface of Mars. is a iron-rich
Okay.
world.
Okay. So for today, we'll end up with the session.
Okay.
Okay. You bring with a lot of questions next week.
Yes, please.
Okay. Yes. Thank you, Abhi.
Thank you.
And thank you, children. Bye. Bye.
Bye. Bye.
Bye. Happy weekend. Bye.
Bye, ma'am.
Bye, dear. Bye. Bye.
Bye.
Bye, dear. Bye. Bye.
Bye.
Bye. Bye. Bye. Okay. Bye. Bye. Bye, dear. Yes.